Hello everyone. So today in this video we are going to see the aromaticity of heterocyclic compounds. So for heterocyclic compounds we have to calculate the number of electrons. It is quite different, okay? So first of all we are going to see a compound. This compound name is Pyrrole, okay? This is Pyrrole. Here this is cyclic. Yes, it is cyclic and all the atoms are sp2 hybridized, okay? So it is planar because see here these two carbons possess double bond, so it has sp2 hybridization. These two carbon has double bond, so it also has sp2 hybridization. And see here one bond, two bond and nitrogen attached to hydrogen, so 3, okay? Here also sp2 hybridized carbon atom, so it is planar, right? Cyclic, planar, and then it has conjugation of pi electrons, right? So since it has conjugation of pi electrons, this rule also is okay, right? So cyclic, planar, conjugation. Then count the number of pi electrons. Here 2, 4, 6, because 2 pi bonds, right? See here 1 pi bond, 2 pi bond. 2 pi bond means 4 pi electrons, and to that 4 pi electrons add this number of lone pair of electrons, one lone pair of electrons, which means 2 electron, right? One lone pair in the sense pair, it is 2 electrons. So 4 plus 2, it is 6 pi electrons. So this compound is aromatic compound, right? This one is aromatic compound. I hope this is clear, right? The next compound is Furan, okay? This compound is said to be Furan. See here. This is also cyclic, this is also planar, and it has conjugation of pi electrons. Now count the number of pi electrons. Here 2, 4, 6, 8. If you write as 8 pi electrons, then it is wrong, okay? If you say it has 8 pi electrons and this system is anti-aromatic, then you are wrong, okay? This system is actually aromatic compound. How? You may have a doubt, right? So here oxygen has 2 lone pair of electrons. If it has 2 lone pair of electrons, how it will be, right? Projection. So see, oxygen has lone pair of electrons in the sense it is in p orbital, right? What's the shape of p orbital? It is dumbbell shape. If suppose, consider, they are perpendicular to each other. I hope you might have known these things. If px, py, pz orbitals are mutually perpendicular, like if this is px orbital, then perpendicularly this will be py, and to py this pz is perpendicular, okay? Likewise orbitals will be present. See here now, why I am saying these things, because consider this furan like this. This is furan, right? See, all the carbon atoms possess this p orbital, okay? Similarly oxygen also has this p orbital. See, all the carbon atom has double bond in the sense it has 2 electrons, right? So one electron from this carbon, another electron from this carbon, it creates a pi bond. Similarly it creates a pi bond, and here oxygen has a lone pair of electrons, right? Oxygen has a lone pair of electron. So it will be like this. Oxygen is having one lone pair of electrons here. This is px orbital, okay? This dumbbell shape is px orbital. Here it possesses one lone pair of electrons. The next electron will be present here, py, okay? Px is here, py is here. See, all these should be planar. This and these orbitals will be in conjugation. But what about this lone pair of electrons? What about this lone pair of electron? It is perpendicular to the plane. Since it is perpendicular to the plane, it cannot take part in conjugation. I hope you can understand this concept. Once again I am telling you that these furan, here all the carbon atom possess 1 electron and here 2 electrons. These will be in conjugation, but it has 2 lone pair of electron, another lone pair of electron will be perpendicular, so it cannot take part in conjugation. So whenever you have two lone pair of electrons, you should include only one lone pair of electron. Okay. See here, for furan, it is 2, 4 and 6. You should not include this pi electron. Okay. Therefore, it has 6 pi electrons, and this system is said to be aromatic system. Okay. The system is said to be aromatic system. Similarly, can you find out the aromatic nature of this particular compound? This compound is known as thiophene. Okay. Since it has sulfur, it is thiophene. See, in the examination, they won't give you these lone pair of electrons and all. They will provide you like this. You must know that the sulfur comes under the oxygen family. Oxygen, sulfur, selenium, tellurium, polonium. So, you must know these things. Okay. So, sulfur comes under oxygen in the sense, since oxygen has two lone pair of electrons, sulfur should also possess two lone pair of electrons. Right? I have already told you the concept. If it has two lone pair of electrons, then one will be in the plane, right? In the plane, among the plane. Another one will be perpendicular, so you should not include those lone pair of electrons. Hence, the system is cyclic, it is planar, and it has conjugation of pi electrons. Count the number of pi electrons. It is 2, 4, 6. Okay, you should not include this 2. So, it is 6 pi electrons, and hence this compound is also an aromatic compound. Okay, this compound is also an aromatic compound. Okay, the next compound is pyridine. Okay, this is said to be pyridine. Here, see, all the atoms are sp2 hybridized. It is cyclic, yeah, of course. It is in conjugation of pi electrons. Then, count the number of pi electrons. Here, 2, 4, 6, 8. If you count like this, this is another mistake. You can ask, in the Pyrrole, we have only one lone pair of electrons and we have counted. But here, we are not including this lone pair of electron. What is the reason? There is a rule, okay? There is a rule. See, it is a trick. Okay, actually, I am going to tell you a trick. Whenever you have lone pair on nitrogen and this nitrogen has a double bond closer. Okay, if it has a double bond nearer to the nitrogen, then you should not include this lone pair of electrons. In the Pyrrole case, see, in the Pyrrole, there is no double bond near nitrogen, right? That is why we have included the lone pair of electrons. But here in pyridine, see, here single bond, but here to the nitrogen, it has double bond. So here you should not include this lone pair of electrons. I hope you can understand this concept. See, whenever you have lone pair of electrons on nitrogen atom and a double bond nearer to the nitrogen atom, you should not include those lone pair of electrons. Okay, here lone pair of electrons should not be included because here one double bond. But here in Pyrrole case, it has lone pair of electrons, but nitrogen has no double bond, right? So you can include. Okay, this is what I am saying. So in pyridine, you should not include this lone pair of electrons. And now count the number of pi electrons. It is 2, 4, 6. In pyridine also it has 6 pi electrons. And hence this compound is also an aromatic compound. Okay. So in today's class we have seen 4 heterocyclic compounds, right? 4 heterocyclic compounds. What are they? First we have seen Pyrrole. The next one we have seen Furan. The next one is Thiophene. And the next one is pyridine, right? Why we are saying these compounds are heterocyclic compounds? Because it has a heteroatom, right? Since it has heteroatom, these compounds are said to be heterocyclic because it has cyclic nature also, right? So we have seen the aromatic nature of these compounds. Okay, here there are 2 examples. The first one is imidazole and the second one is indole. For these 2 compounds, I am not going to calculate these pi electrons and I am not going to give you the answers. You are going to find out the answer and just post it in the comment box. Okay. So the first one is aromatic or not, and the second one similarly it is aromatic or not. You have to find out and just share your answer. I will just check it whether it is correct or not. Okay. In the next video, we will see the aromaticity order. Okay. It is very important question. It was frequently asked in both CSIR and JAM. Okay. So we will see the aromaticity order in the next video. Stay tuned. Thank you for watching.